Hello, my name is Mohammed Saeed Abdurrahman. I am mechanical power engineer. Have a position in CEO of engineering tips company. This company is introducing some technical courses for mechanical engineers for 3D simulation and for modeling, also for technical courses like mechanical design of the pipes and fitting on the steam pipes. Course is especially introduced for the steam settings, valves, and some heavy equipment and boiler room house. So in this course, I will explain some fitting in the piping system of the steam boiler, like separator and how to design valves and software to facilitate in selection of the valves and what's the meaning of steam traps and the difference between the different types of steam traps. Also, I will classify how to select a selection of your boiler and how to design the boiler room and how to selection of the sizing of the fittings and the piping, also valves, and what's meaning of the capacity of the valve and how it's affect the selection of your boiler room. This is the first episode about separator. Separator, its main function is to remove the water droplets entrained in steam to increase its efficiency. So in steam, there is a many problem when the water is entrained, a water droplet is entrained in a steam, it's become a wet steam. When the steam is wet, there is a many hazards results in these phenomena, like water hammering and wire drawing, and these case the damage in plug and seat of the valves. So in other way, I have to fit separator when I want to use a dry steam. So to get a dry steam, I have to fit a separator and select the size of separator, and we will learn how to select these appropriate size. So the main function of separator is to remove wet, is to remove a water droplet from the steam. Okay, because this droplet, this can make a very damage, like it decrease the efficiency of heat transfer. The temperature of the steam temperature is that, and the air film makes the heat transfer decrease, also moisture, also scale, also the water droplets in the steam. Because the specific volume of the steam is very large than the specific volume of water, 16 times more than specific volume of water, so the steam, when it's moving with the water in the same pipe, so the steam may take a measure of the specific volume of this pipe, and there is a little volume of water. So according to Bernoulli equations, the water have a very high velocity due to this small area, small specific volume. So it's moved with a very high velocity. This make water hammering, and this makes the damage in the valve seats. All these damages, I can prevent it by fitting a correct separator. Okay, this is the main function of separator. Okay, steam produced in the boiler designed to generate saturated steam inherently wet, or the dryness factor will vary according to the type of the boiler. Okay, so there is three types of steam separator. So steam separator can be a baffle plate steam separator, or can be cyclone or cold sealed steam separator. So there is a 3 types, and I will explain there's 3 types. Okay. There is steam inherently wet of the dryness factor. And I will explain how to measure the amount of the steam separator can remove from the total amount of water entrained in a steam downstream separator. Okay, there is always a certain degree of heat loss of distribution with case condense. So I can talk with you why the steam entrain and the water droplet entrain as steam. Because the pressure drop according to fittings and the piping, so when the pipe move horizontally meet 100 meter, there is a 1 bar pressure drop. This pressure drop is it's the main reason for condensate of the steam. So when the pressure of the steam reduced, so it condense, and when it condense, the water entrained in the steam, so I have to put steam trap or I have to put separator to remove this condensate to avoid this damage setting of water hammering or corrosion or many other results that can make damage in my steam system. Okay, then the generated steam inherently wet, the dryness fraction will vary according to the type of the boiler. Okay, there is always a certain degree of heat loss distribution with case of steam to condense. Okay, in this he explained the effect of the water entering the steam and how can it damage the valves and the plugs and make it water hammering and decrease the heat transfer coefficient, so it leads to a decrease of the efficiency of the steam to transfer with another fluid to make it useful use. Okay, water droplets traveling high steam velocity will erode valve seats, fitting conditions, and withdrawing water droplets will increase the amount of corrosion because it contains of oxygen. This oxygen may make oxidation and make corrosion of the steam pipes. So it's a very dangerous phenomena I have to prevent from my steam boiler. Increased killing of the pipe heating transfer impurities, erratic operation control valve flow meter, failure of valves and flow meter due to rapid water and water hammering. Okay, there is the first type of separator. The main function of separator is to remove steam, as we talked in previous minutes. So when the wet steam come from these flange connected to the pipe in here, flange connected to the other flange in here, and in this course I will explain the many different types of flanges and flange faces and many other types, and how I connect this fitting to the steam pipes, and how I connect pipes to the flanges, and many other interesting things that may help you to be more and more efficient as a mechanical engineer. Okay, when the wet steam entrain in this separator, there is a part, there is a steam and water droplets together mixture hit to these baffle plates. So the large size of separator make the baffle plates many baffle plates, and when this mixture hit these baffle plates, the steam is lower dense than water. The water is high than the steam, so the water collect and drop according to gravity in this direction, and collects in the port condensate to steam trap. So I will put here a steam trap, and I will talk about steam trap components and how can I design steam trap, a correct steam trap for separator and for many other things. And when I have to fit steam trap in my steam system, so the water droplets collect together and goes out with this port of steam trap condensate, and the steam, dry steam, is go out of here. So these baffle plates is more and more efficient from 10 meter per second velocity of steam to 30 meter per second. The efficiency of separator is 98%. So this is a very good efficiency when the steam velocity from 10 meter per second to 30 meter per second. So this is a working principle, is a large size of separator, make the mixture goes more and more volume, this good in loss pressure drop, and this make a steam move around the baffle plates, and the water entraining steam is collected together and goes down according to its weight and according to gravity from this port of condensate steam trap. Okay. So this is the first type of steam of separator. So let's read these lines together. Baffle of the van type separator conserves the number of baffle plates, which gives the flow to change direction number of times it passes through separator body. The spilled water droplets have a greater mass and a greater inertia, like I can say, when this change in flow, so the steam move around the baffle plates and water droplet collect together and get rid of separator from the condensate port, and I will fit steam trap set in this port to remove condensate into condensate tank or into the drain, into the flow down vessel, into flash vessel. So I will use it as a recovery heat source. Okay, separator has a large area. This results in reduction in speed and reduced kinetic energy, and this is a working principle of first type of separator. Okay, the second type of separator is cyclone type, and I have simulated, and I have drawn some 3D to show a cyclone separator. Cyclone separator is its main principle is a centrifugal force and inertia and moment of inertia. When the steam is coming from here, and very high velocity of the steam and water droplets, and by tangential velocity or linear velocity of when I have circle, and there is a linear velocity is here. When I move with the linear velocity, this water has more inertia than steam, so it hits the walls and move around and around and around and around and around and around and go into bottom with a condensate steam trap set. In the steam trap set, there is a water collect together in here, and the steam is passed away from another port, like I can see here. Okay, so I will explain that. Steam comes from here, and there is a path of the no, it's a different type. This is a cyclone type that I have explained right now. So steam come from here and move around and around and around according to the inertia of the water, the centrifugal force, and move around and around. And dry steam is float according to it has a less moment of inertia, so it can not swirl as a water droplets swirl. So the water droplets is come from here to steam trap set. I will fit to here, flange it. So I can take these condensate and water droplets together and make it back to condensate pump or to condensate tank or to blow down vessel, flash vessel, or drain system. So the dry steam is coming from it. The working principle is centrifugal type. Centrifugal force uses a series fans to generate high-speed cyclone flow. The velocity of steam gets to swirl around the body, throwing the heavier suspended water to the wall. When it drains down the steam trap installed under. Okay. So you can figure out the second type of separator is a cyclone type. This is the main function of cyclone type is a centrifugal force of the water droplets entrained the wet steam when this velocity is hit in this wall. So it swirl and swirl and swirl and collect together. So it's come to the steam trap. I will fit in this port of separator, and I will study how to select the same and appropriate size of steam trap, pipes and valves, and the types of steam traps according to our course. So the dry steam is come from this port and go to make its function to heat transfer or to turbine. It's advisable. It's more appropriate when using steam to the turbine is to be superheat steam, not only saturated steam. Okay, but saturated steam is more and more efficient because HFG is more and more. So I will more efficient to heat transfer, plate exchanger, to calorifier, and to make a process of heat exchanging with another secondary fluid to take this enthalpy and amount of heat and use it in the useful way. Okay. Okay, like warming, swimming pool, or many other or many other application. Separator efficiency measure amount of water separated out in the portion of total weight of water carried in the steam of the laboratory. To take the efficiency of any separator, it's amount of water removed from the wet steam ratio with the total amount of water entrained in water steam. So I can say I will use Holocene type separator or cyclone when the velocity is less than 13 meters per second, and I will use baffle plates when the velocity is from 10 to 30 meters per second, because the efficiency of cyclone and Holocene type separator is a very, very, very low when the steam velocity is 25 meters per second. So baffle plate is a highly recommended to use in a steam application. Okay. So the last type of separator is Holocene of steam trap, Holocene type separator. So the wet steam come from these ports and move away to this port. So it has a wire mesh in this way. So this wire mesh is a very, very fine mesh. So the water droplets come from this mesh, and the lower dense steam is goes with it, and according to its lower dense, so it's move another time to this wire mesh. This is improve its quality of dryness ratio. So steam move together here and steam move another way here and come to be a dry steam out of here. And So a dry steam is coming out of this port, and the water droplets collect together and come to this condensate port to the steam trap fitted out of here. Okay, so according to 3 types of separator, I recommend to use baffle plate in a steam application from 10 meter per second to 30 meter per second steam velocity, and glycine and cyclone when the steam velocity is less than 13 meter per second. Okay. Okay, and separator efficiency is the amount of water removed to the total amount of water in the steam. Okay, the water in the steam may cause corrosion, water hammering, erosion, and may cause damage of the plugs and seats of the valves. Okay, so how to calculate the efficiency of the steam and dryness factor? This example, even a separator efficiency is 90%, is fed in a steam main containing steam with dryness factor 0.95. What would downstream dryness factor? So I have efficiency, I have efficiency of separator and dryness factor. So dryness factor, when I assume the amount of kilogram steam is 1 kilogram 1000 gram, so 1 minus 0.95 multiplied by 1000, so 50 gram of water is the total amount of water entrained in the steam. So the efficiency of dryness factor, it's 45 gram of water present removed. So this percent, this gram, this amount of water is removed according to FET steam separator, because the efficiency of separator is 90%. So the dryness factor will be like that. Okay, okay, this slide is attached in the description of this video, so you can read it and revision all the information with yourself, and to be more and more effective to select a type of separator and to penetration of your understanding of a steam application and steam fittings. Okay, the pressure drop about the baffle plate separator is very low because it has a large capacity. So when I increase the size of separator, this is a point of discussion with next 10 minutes. So make your brain concentrate with me to this point, because it's important point. Okay, I will talk about how you have the information that I will use baffle plate in a steam application when the steam velocity is 30 meter per second, and I will use cyclone and glycine type steam separator when the velocity is less than 30 meter per second. What if the steam velocity is 50 meter per second? When the steam velocity is 50 meter per second, I can make something tricky with a steam separator to increase its size and increase the size of this flange. I will use a baffle plate, but I will increase the size of this flange, increase the size of this flange to increase the size of the pipe itself, so it can fit to the safe region. I will show that by this graph. When I use, concentrate with me, when I use, my steam pressure is 12 bar pressure, and mass flow rate is 500 mass flow rate. So and my steam pipe is DN32. If I locate it in this shaded area, so I am in safe region and my separator has a high efficiency. So when 12 bar, So I will select separator according to pressure and mass flow rate. I will select the size of separator, the size of flanges, size of pipes according to pressure and mass flow rate. So I have, in this example, I have upstream pressure 12 bar and passing 500 kilogram. What the size should be separator be? Okay, and what's the pressure drop? So I have 12 wet steam pressure or pressure and intersect with this curve of 500 mass flow rate. So I take a horizontal line to this DN32. This is my pipe, DN32. DN32. Okay, I will hit DN32 in the shaded region, so I am safe, and I will take a vertical line to intersect with this curve, and I will get a pressure drop across the separator. So what if in the same operating pressure 12 bar, I have to remove the water entrain and steam when the mass flow rate is 1000. So 12 bar intersects this curve of 1000, and I will hit 32 outside of this shaded region. So there is an unsafe separator, and there is a very, very, very low efficiency. So I have to increase the size of the pipe here to DN40 to be located in this shaded area. So when I 12 bar steam to 1000 mass flow rate, so to be in the safe shaded region, I have to increase the size of the pipe itself to be in shaded area and to increase the efficiency of separator. So I take a vertical line like twice, and a pressure drop will be low. Is a good method to increase efficiency. This is a good method to increase the efficiency of your separator. Installation, it's important to take in wise that the installation is a very, very, very important thing in separator, because separator is used to remove wet steam from, to remove water droplets and train in the steam to be made a dry steam. If you have an insulated separator, so you will collect more and more and more water, and it may to take wet steam in inlet and wet steam in outlet according to uninsulation and more percentage of condensation of steam. It's make your efficiency very, very, very low. So you have to insulate the separator to make its good efficiency. Okay, so I use insulation jacket that's designed for particular separator. Okay. Let's talk about the installation of separator. So this is the end of my lecture. I will solve with you some question together. Which of the following case water entrainment and steam? Which of the following? Priming and carryover of water boiler, heat loss in pipe, production of saturated steam in boiler. All these reasons will make steam condensate and will increase the percentage of water droplets in steam. Priming and carryover of water, very, very, very maximum load according to the boiler. So the boiler make more and more and more energy, and feed pumps water, more and more water. So the level of the water increased. So when the steam is generated to the steam main valve, the water entrained with the steam. So it's first reason. Second reason, heat loss in the pipe. If your pipes is uninsulated, so the pressure drop is very, very large, and the enthalpy consumption is very, very large. So the heat loss is very, very large. According to that, this is a pressure drop in the condensate, and it make the steam condenses and water entrained in steam. Production of saturated steam in the boiler. All above cases of water entering in steam. Although in practice it's difficult to measure dryness fraction of steam, which of the following factor provides a good indications of what steam is present in a steam system. Erosion and withdrawing water hammer, all these factor, the wet steam is present in steam system. Okay. Dryness factor, temperature and wet steam 90. This is a calculation according to the equation. What's the main advantage using baffle plate separator instead of cyclone colocene? When high efficiency over wide range of velocity, yes. Very high efficiency up to flow 13 meters per second. In this type, the cyclone and colocene type separator is a very high efficiency, less than 13 meters per second. But the main reason and main advantage in baffle plate is high efficiency of wider range of flow velocity. Okay, size a baffle plate, size baffle type separator using the size chart of the following with operating pressure A bar and steam flow rate 1000 and a pipe size 65. So 6 A bar and 1000. So I will go to the curve and I will solve this. It's 8 bar and 1000. So I will hit here. So I will take horizontal with DN 65. So in the shade region, so my size is 65, DN 65. So the right question is DN 65. Okay, okay. Which of the following is a benefit of using insulation jacket? Reduce heat loss, increase efficiency of separator, protection from possibility of burn. Thank you. See you in the next lecture. Hamad Al-Farai, Engineering Tips.